Before we go hands-on, we need a few minutes on what's underneath it. RPC, remote procedure call. The idea is simple. Call a function on a different machine as if it were local. Your code says get weather, but get weather doesn't run on your machine. That call goes over a network to another process. That process runs the function, and the result comes back. From your code's perspective, it looked like a local call, and that's RPC, remote procedure call. It's not a new idea. It goes back to the 1980s. gRPC uses it. The concept has been around longer than the web. What changes between implementations is the encoding, how you serialize the function, name, and arguments to send them over a wire. JSON-RPC is RPC, where the encoding is JSON. That's it. Version 2.0, published in 2010, standardized the exact format. What a call looks like, what a result looks like, what an error looks like. It's a short spec. It doesn't care about transport. It works over HTTP, WebSockets, SSD in, SSD out, Unix pipes, anything that can carry text. MCP is built on JSON-RPC 2.0. Every message between client and server follows this format. MCP didn't invent it. It adopted a proven standard and built its protocol on top of it. There are exactly 3 message types in JSON-RPC 2.0. One field tells you which one you're looking at. The ID. Requests have an ID and a method. They expect a response back. The ID is how the response gets matched to the request. Without it, you can't correlate them. Responses echo the same ID back with either a result or an error, never both. Notifications have a method but no ID. Fire and forget. The receiver must not respond. That's the whole type system. If it has an ID, someone is waiting for an answer. If it doesn't, nobody is. Now, transport. The JSON messages have to travel somewhere. MCP supports 2 transports. stdio. The client launches the server as a sub-process. Messages go out over stdin, come back over std out. Each message is a single line. No embedded new lines. Latency is microseconds. Streamable HTTP. The server runs an independent process. Client sends each message as an HTTP post to a single endpoint. Server can respond with a single JSON reply or open an SSE stream to push multiple messages back. Progress updates, notifications, whatever it needs to stream. The client can also open a persistent GET to receive server-initiated messages. The JSON is identical either way. Transport is just the envelope. The letter inside never changes. Now, the lifecycle. Every MCP connection goes through 3 phases: initialization, operation, shutdown. Quick map before we read the JSON. MCP defines what each side can offer: servers, advertised tools, callable functions, resources, readable data, files, database records, any structured content, and prompts, pre-built message templates for an AI. Clients, advertised sampling. The server can ask the client's LLM to generate text. Elicitation. The server can ask the client to collect input from the human. And completions. The server can suggest valid arguments, values as the user types. We'll go deep on each. Right now, you just need to know they exist. Initialization. 3 messages exactly. The client sends an initialize request. It declares its protocol version and what it supports, sampling routes, whatever capabilities it has. The server responds with its own capabilities, tools, resources, prompts, logging, and its version. The client sends an initialize notification. No ID, no response expected. This is the handshake complete signal. Neither side can do anything else before this sequence finishes. Request, response, notification. 3 messages. Done. Operation. This is where everything lives. Discovery. Client sends tool/list. Server responds with every registered tool's name, description, and input schema. No tool runs, just metadata. Execution. Client sends tools/call with the tool name and arguments. Server runs it. Returns the result wrapped in content. Notifications flow in both directions throughout. Server sends notifications/tools/list_change when its tool list changes. Server sends notifications/progress during long operations. Client sends notifications/cancel when the user bails out. All of it is the same 3 types: request with ID, responses matching that ID, notifications with no ID. Shutdown. MCP has no shutdown message. The transport handles it. stdio, client closes std in, waits for the process to exit, then terminates it if needed. HTTP, client closes the connection. Session ends. One more thing worth locking in. Capabilities aren't just informational. They are a contract. If the server didn't advertise tools in initialize response, the client can't call tools. If the client didn't advertise sampling, the server can't ask the client to run LLM inference. Neither side can use a feature the other didn't declare upfront. That's why the handshake exists. Not politeness, enforcement. You've now seen the full wire. RPC is the concept. Call a function on another machine. JSON-RPC is the format encoded as JSON. MCP is the protocol. Define exactly which methods exist, in what order, with what structure. Everything in the next section. Every session call, every decorator, every content envelope was producing these exact messages. FastMCP handled the serialization. Now, you know what it was producing. Next, we build the actual code.